Hi, everybody. This is Mr. Folly, and welcome to podcast 3.1 modeling, where we're going to learn if we're given a heating or cooling curve, identify the phases present, phases meaning states of matter. And given a heating or cooling curve, identify the melting freezing point and boiling condensing point. And then given a heating cooling curve, I guess I'm giving you a lot of those, we're going to identify what type of energy change storage mode is changing for each section. So that's going to either be E thermal, change in temperature, or E phase, change in phase. Given a temperature change and or phase change, draw the heating curve. So let's hop to that. Here we go. The heating and cooling curve. So a heating curve looks like this. Notice how it's going up. The axes are temperature, right? Temperature in degrees Celsius. And it's either going to be time. This says time. I'm going to change it to, we'll get back here. I'm going to change it to time of, in this case, it's going to be cooling. Or this says heat added, or it could be time of heating. Either one is fine. Basically, we're just heating something or cooling something. I can tell this is heating because the temperature's going up. I can tell this is cooling because temperature's going down. Okay? So the plateaus are phase changes. Okay? My phase changes are either going to be melting, or freezing, and that happens at the same temperature, or it's going to be boiling, condensing. Okay? So this first one right here happens at -60. So the plateaus of these phase changes. So if I'm starting out down here, the coldest state of matter would have to be a solid. So A is going to be a solid. Okay? B is going to be melting. Now if it's melting, it is both solid and liquid. Okay? C is pure liquid. D is boiling. Oh, why do you change on me? D is boiling. Right? D is boiling. And if it's boiling, it's both liquid and gas. And then E is just gas. Okay? So the plateaus are the phase changes. So that's where we're going to see melting, freezing, or boiling, condensing. The slants are the temperature change. So look, this A part, see where this is slanting? That's a temperature change. Okay? So the energy change for the temperature changes are in region A, C, and E, and that's where the thermal energy is changing. See how it goes from -100 to -60? And see how it goes from -60 up to +60? And see how it goes from +60, in this case it stops about, 70, 80. Okay? The plateaus are where now notice we're heating it all the time. So when I heat this, I'm heating it. When I heat it, sometimes the temperature doesn't go up. So where does that energy go? So when I heat it and the temperature doesn't go up, it goes into the energy of the phase. I better write that down. When heating, that means you should be writing it down too, and temperature doesn't change, the energy is going into EPH. That means the phase change. Okay? All right. So to help you identify this in case this is crazy, so the bottom one, whenever I have two slants, the bottom one will always be the melting or freezing one. And the top one will always be the boiling or condensing one. Okay? So the solids are colder than melting. So again, the top one here, this is going to be boiling. It's not going to be boiling, though. It's going to be the opposite. It's going to be condensing. Why is it condensing? Because it's getting colder. So this won't be freezing, this will be melting. So what state of matter is colder than melting? Solids are colder than melting. That's why this is a solid. Liquids are warmer than melting and colder than boiling. That's why this is a liquid. Gases are hotter than boiling. Gas. Okay? So that's not too bad, I think. How do we find the melting and the boiling points? Why are all these things still here? Let's see if I can make them go away. I doubt it. No, I can't even make it an eraser. Okay. Oh, there they went away. How do we find the melting and boiling points? They are at the plateau. Melting is lower than boiling. So see, here's a plateau. So on this guy, the melting point is right here, 1500 degrees Celsius. Here, this is 2500, this is 3000, so this is about 2750 equals the boiling point, because that's where the plateau is. This one, melting point is 0 degrees Celsius. It's the lower plateau. Plateau is a flat line. Boiling is up here and comes up here. That's 100 degrees. Boiling point equals 100 degrees Celsius. It's the higher plateau. That's it. Okay? Energy storage modes, F and P, if. Okay? Energy thermal. Thermal is movement, right? Which is temperature. So wherever the temperature changes, hey, look right here, the temperature is changing. That's ETH. Oh, look here, the temperature is changing. That's ETH. Oh, look here, the temperature is changing. Yeah, you get it. Oh, look, the temperature's changing. Oh. Oh, look, the temperature's changing. That's ETH. Oh, look. Now, what do you mean by the temperature's changing? See how it changes from here to there? That's ETH. Look here. The temperature's changing. It's going down this time. That's ETH. So when you change, so I guess I'll do this one first. When you change the temperature, you change ETH. Okay. When you change the state at the plateau, you change EPH. Let's see if I can change my color. I can. This guy right here is the flat part. I'm still adding heat to it, so it's EPH. The phase is changing right here. That's changing energy of the phase. I'm not getting warmer. My energy is changing my phase of matter. That's energy phase. I'm not getting warmer. I'm using that energy to change my phase of matter. That's EPH. Here's cooling. I'm not cooling. I'm using that energy to change my phase of matter. That's EPH. So EPH is a phase. What are the three phases of matter? You know this. Solid, liquid, gas. And then Alec will want to talk about plasma, but we'll ignore that. The heating curve, oh my goodness, for sodium acetate is given below. Hey, hi sodium acetate. Draw the heating curve for sodium acetate from warming from 20 degrees to 90 degrees. So right here is 20, right here is 90. So all I have to do is do my temperature, label my axes, degrees Celsius, and time of heating. Now I know it's going to go from 20, and I know it's going to go to 90. So, boop, now I don't have to worry about it changing state of matter, right? And it's going to be a solid all the way through, right? And the energy change here is going to be, it's a slant, so change in temperature, ETH, okay? Now I'm going to do the same thing, temp, degrees Celsius. I'm not going to use these things anymore, man, are they annoying? And then the time of heating, get back here. From 2000 to 4000. So do you see how right here 2000 is going to be a liquid? So I'm going to put a mark right around here and say 2000. And I'm going to go to 4000. Notice how the 4000 is going to, I need to include the melting point and the boiling point. So the melting point, right, get back here. The melting point is at 1500. And the boiling point is at 2750, right? So I'm going to start warming it up, but once I get to 2750, I have to stop. And I have to, what happens here? I have to boil. Okay? So here, I'm going to change temperature. Remember, triangle means change. Change in temperature, boil, change in temperature. So when I have change in temperature, I have energy thermal. When I boil, I'm changing state, energy phase. And then I'm changing temperature again, energy thermal. Water freezes at 0 and it boils at 100. Draw the curve for water warming from 90 to 110. So water freezes at 0. This is 0. This is the melting point. We'll call this 100. This is the boiling point. So I'm going to start at 90 and go to 110. This is, get back here. This is 90. This is 110. Start right here. I'm going to end right here. So slanty up. Okay. So when I draw that heating curve, get back here, I have to change temperature, change state, change temperature, change temperature, change phase, change temperature. So I cannot change from a liquid to, well, I have to change from a liquid to a gas. I can't be a liquid at 110. Draw the curve for water cooling from 110 to -5. Oh boy. So I'm going to do my 0 degrees is my melting point. 100 degrees is my boiling point. I'm starting at 110. I'm going to end at -5. So I'm going to start right here and I'm going to end all the way down here. Slanty, slanty. Uh-oh. Now what's happening here is not boiling, it's condensing. And what that means, it goes from a gas to a liquid. And what that means is I'm going to do energy phase. Then I'm going to come down here and I get to my melting point. But I'm not melting, I am freezing. And if I'm freezing, I'm going from a liquid to a solid. And then I'm going to go down here and I'm going to change my temperature. Get back here. So I think we're pretty good with realizing that whenever we do a phase change, we do energy of phase. But whenever we're here and here and here, these heres are energy thermal. Hey, perfect timing for once. Review. Plateaus are phase changes in energy phase. Slants are temperature changes, energy thermal. Plateau tells you where the melting point and boiling point are, and those are in degrees Celsius. Solids are at the bottom, liquids are in the middle, gases are at the top. That's how you throw a curveball. That's all I got to say about that. Toodle.